Hey everyone, have you ever tried chatting with a website? Now, that's a stupid question, I know, so let me explain what I mean. Imagine you have a Tesla Model 3, you want to know how to turn on the autopilot. So you open the autopilot documentation, you start looking around, and you see how long the page is and how tiny the scroll bar is. And you start thinking, this is silly. There must be a better way. Now, it's 2025, and you know you can just ask AI to tell you the answer. And since you're a programmer, you decide to do it the proper way and write a script to do it. So you have your question, how to turn on autopilot, and the URL of the page where the answer is hidden. And it's simple, right? You fetch the URL, you parse the response, you extract the body of the page, you write a straightforward prompt, GPT-4o, and you get nothing. So you think, this isn't working. Let's try something else. And you buy a BMW. Now the BMW has some issues, and you have to restart the built-in infotainment. So you adjust your script to load the BMW website, you change the question to how to restart iDrive, and you still don't get anything useful. Now, eventually, you find out that the Tesla website blocked you from downloading it, and the BMW website is rendered dynamically in the client on the browser, so the fetched HTML really does not contain any useful information. Hi, I'm Franta. I'm a full-stack engineer at Apify, and today I want to tell you how to do it if you really want to chat with a website. So let's take a look at the agenda for today. As we saw earlier, fetching the page content is problematic. So first, we'll talk about how to do it reliably and how not to get blocked. Next, we'll talk about how to parse the fetched pages so that we can feed only the actual content to the LLM and not all the other junk that's on a website. Once we're able to fetch the web pages and parse them, we'll talk about how to do it at scale, so you don't have to fetch the website page by page, but you can do it all at once. And last, we'll put it all together and do a quick demo of creating a chatbot with LangChain. Now, at Apify, we have a tool called the Website Content Crawler, which does all the scraping and parsing for you. And the things I'll be talking about today is knowledge that we learned during the development of this tool. And the Website Content Crawler is not just some toy project, but an actual product used, for example, in Intercom's Fin. Fin is a chatbot that you can embed in your own website, and it allows your website's visitors to chat with the website. And for Fin to be able to do that and to answer their questions, it actually scrapes your own website using the Website Content Crawler by Apify. So let's take a look at the specifics of getting the clean web data. First, we have to fetch the web page content reliably without getting blocked. And fetching a web page should be simple, right? You can just use a normal HTTP client like curl to get the content. Unfortunately, the websites will detect that you're not a regular user, and they will block you. To not get blocked, you need to look like a real human to the web server. A real person does not look like this. They look like this. These are all the headers a browser is sending along with the HTTP request to the server. There's the browser version, whether the browser is a mobile device or not, what languages does the user accept, what compression, and so on and so on. And it's not just about the headers. Web servers can detect if you're a bot based on the encryption algorithm you're using in the request, or the HTTP version. Most browsers now use HTTP3, but a lot of clients don't support it yet. And dealing with all of this yourself would make your head explode. But fortunately, there are ready-made tools and libraries which take care of it so you don't have to. One such tool is curl impersonate, which is a special build of curl, which behaves like any of the major browsers you can choose. Another tool with similar features is impit, which is a library written in Rust, but it has bindings in Node.js and in Python coming soon. So let's try it. We take the same simple code as in the beginning, except we don't fetch the page normally, but we impersonate Chrome through impit. And we have our answer. To turn on autopilot, follow these steps. That looks about right. So, is our behavior human enough? Unfortunately, not yet. In our simple script, we just loaded the website's raw HTML, but browsers also execute JavaScript. The BMW website is lazy loaded, which means that the first HTML response does not actually contain any useful content, and the content is rendered only later through JavaScript code. That's why, for scraping some websites, we have to use actual browsers. There are a bunch of libraries you can use, which allow you to control a browser. You've probably heard about Selenium, which used to be the most popular library for a long time. And these days, it has competitors in Playwright and Puppeteer. Each of those allow you to control multiple kinds of browsers, like Chrome or Firefox, and open web pages and inspect their content through them. We'll use Playwright. Since it's the most modern of them all, it is available for Python and for Node.js. So in just 5 lines of code, we can open a browser, launch a tab, load a URL, and get its content. Now, to actually get the content of a lazy loaded website, you have to make sure that you wait for the web page to finish loading. That's why, when we're loading the web page, we wait for the network idle browser event, which indicates that there is no network activity anymore and everything is already finished. This might be overkill for some pages where the content is available earlier, but for the general use case, where you don't know which website you'll be scraping, this is a surefire way to know that everything is already loaded. And now even the BMW website is responding to our questions. So the Tesla and the BMW examples worked, which is great. But for the universal use case, this is not enough. There are a lot of clever, creative bot detection softwares that we have to fight. You probably know Cloudflare, which has one of the best bot protections on the market, and it's used on a lot of websites. And yesterday they were giving out free beer here. If the website was using Cloudflare protection, it would block even our script with the browser automation through Playwright. That's because, by default, the headless browsers actually identify as headless browsers in their user agents. The anti-bot software uses the user agent, the headers you send with the request, the details about your browser and your hardware, to create what's called a fingerprint of your device. And based on that fingerprint, they decide whether you're a real person or a bot. So to appear as a real person, you have to have a real fingerprint. It's not enough that all the properties in the fingerprint make sense. They also have to make sense in combination with each other. So for example, you can't have a 2024 MacBook Pro with just 8 GB of RAM, because that's not a real device. You need at least 16 GB. Unfortunately, there are a lot of libraries that help you deal with that and have a real fingerprint. There are stealth plugins for Puppeteer, Playwright, and Selenium, or you can use a full-blown scraping library like Crawly, which is available for both Node.js and Python, and which helps you manage the scraping and impersonation all at once. Now, at this point, you might think, I don't want to deal with all that. I just want to simply scrape a web page. And there are a bunch of web scraping APIs that allow you to do that. Shout out to Brightdata, with the API taking care of the blocking and the impersonation. And they're great if you want to quickly start with scraping, but once you need to fetch thousands or hundreds of thousands of web pages, they quickly became costly because you have to pay for every single page. So now we know how to reliably get the HTML content of the page. The next step is parsing the HTML so that we can feed it into a large language model. If you look at the web page, there's a lot more to it than just the content. There's the menus, the search bars, the navigation, the headers and the footers, and so on. So if you look at the HTML, you can see that it's pretty complex with a lot of scripts, styles, long attributes, and whatnot. And you don't want to feed that straight into the LLM. First of all, a big HTML eats a lot of tokens, so it's slower to process, and it costs more. And it might not even fit into the model's context window. And second, there's a lot of content fed into the model, so the actual data you need might get lost, and the model might get confused. That's why we need to extract the actual content from the web page and throw away all that fluff. And there are a lot of things you can try to do that, but don't waste your time and start with Mozilla's readability library. Readability is what's powering the reader view in Firefox, which strips away the clutter like advertisements, images, buttons, and so on, and just leaves you the content of the web page in some nice unified format. And readability is a great start, but it's not bulletproof, and it doesn't strip away everything, sometimes keeping the menus or the footers. So you have to post-process it still. For a lot of use cases, you want to search through the web pages using vector search, so you have to keep that noise out of your embeddings. If we look at the Tesla website, the menu on each page contains a lot of keywords which could confuse the vector search. If the menu was present in the embedding of each page, the vector search on the embeddings wouldn't work because it would be hitting the keywords in every page. And to remove the menus, we can use an algorithm such as the count min sketch, which goes through the pages, detects which lines appear in the majority of them, and it removes the shared content and leaves you just the unique content of each page. Readability is not also 100% reliable in removing the cookie models and various pop-ups that you get on the web page. And for that, you can use browser extensions compiled for Playwright, such as the I don't care about cookies extension or various ad blockers to get you just the content. So now that we've removed the unneeded content, we can convert the HTML into Markdown. Markdown is better than the HTML because it doesn't contain the HTML elements, so it's shorter and it contains almost just the text that you need. But it's better than just plain text because it keeps at least a bit of the contextual information in the web page, and it has some indicators of what's important and what's not. So now we can reliably download the page, and we can extract the content from it. Now, we have to scale this solution so that it scrapes all the pages in a website. The first rule of that is ignore sitemaps. Sitemaps contain a lot of fluff, like honeypots, designed to trap scrapers with useless links that the user can't accept, but the scraper can't escape from. You need to click through the website as a real human would, through the normal navigation, respecting the categories, and clicking only on visible links. But as always, there's a lot more to it. You have to deal with extracting the links from the web page, with enqueuing and deduplicating them, with correctly managing the concurrency of the scraping so that you're scraping fast enough, but also not overloading the web page. And the answer to that is, again, libraries. There are a bunch of libraries that you can use to help you deal with the enqueuing, concurrency, and state management. For example, Scrapy is one of the oldest and most popular web scraping libraries out there, and it's available for Python. And there's another popular alternative, Crawly, which is available for Node.js and recently also for Python, which on top of the crawling management also allows you to control browsers and scrape through them. Websites often show you different versions of the content, different products, and different prices based on the country you're accessing the website from. So if you want to scrape the website as it would appear in a specific country, you have to use proxy servers located in that specific location. And there are two main kinds of proxies. There are data center proxies, which, as the name suggests, are just servers living in server houses around the world. And they're great. They're fast, they're cheap, they're reliable. You can scrape with great bandwidth through them. But they have one main disadvantage. Since they're in data centers, it's easily identifiable that they're not real servers. And their IP addresses aren't listed on known scraper IP address lists, so the web pages can block them easily. And the second kind is the residential proxies. These are proxy servers running on devices of real people around the world. And they're not botnets. The people running those servers are actually voluntarily providing a part of their bandwidth, and they're getting paid for it. And that makes them hard to block, because blocking them would be actually blocking real people, not servers. But it also makes them quite flaky, because you never know how fast the server will be or if it will be even online. And due to their nature, they are also quite expensive. So if you need to use proxy servers for your scraping, there is a simple rule to follow. Always use data center proxies. Only if they get blocked, use residential proxies. So now that we've talked about the whys and the hows of scraping, let's put them to use and create a simple chatbot with LangChain, which is a popular framework for creating large language model-based applications. We'll start by scraping the whole Tesla Model 3 owner's manual. We'll use Crawly for that, and from Crawly, we will use Cheerio Crawler. And to Cheerio Crawler, we will pass a function that we run on each scraped web page. This function gets the scraped web page parsed through Cheerio, which is a library for working with HTML in Node.js, and it finds all the links that match the URL we want to scrape, and then enqueues them for further scraping. So if we run it, we can see that it first scrapes the main URL we supply to it, and then all the child URLs that are linked from there. And now that we're scraping all the web pages, we'll have to parse their content. First, we'll feed the web page to the readability library to get the simplified view of the web page. The readability doesn't work directly on HTML, so we have to create a document object model to pass to it using JSDOM. And then we'll take the simplified HTML from readability and turn it into Markdown to save on size. We'll export the scraped dataset into a CSV and load that CSV into LangChain. All the building blocks are starting to fall into place. And then we'll need to put the documents into a vector database so that we can query them easily using the LLM. We'll need to split them into reasonably sized chunks with some overlap, for which LangChain has some built-in methods. And we'll create embeddings out of those chunks. We'll be using OpenAI in the chatbot, so we'll create OpenAI embeddings. And finally, we'll store the embeddings into a vector store. We'll use just an in-memory vector store for this simple demo, because it's enough. For a real use case, you would probably be storing it into some vector database, such as Chroma. And finally, we'll ask the actual question. We'll create a chatting model for OpenAI, which will take the question, find the right document to answer that question from the vector store, and then create an answer for the question based on that best document. So if we ask the chatbot what is Autopilot and how to use it, it will give us the right answer. Autopilot is a driver assistant feature in Tesla vehicles, and so on, which looks about right. Now, let's try adjusting the chatbot for the BMW website. We just need to change the URL, change the question, and change the scraping to use Playwright Crawler, since the BMW website is client-side rendered, so we have to scrape it using a browser. And we start it. It scrapes the articles on the BMW Help website, and it gives us an answer. iDrive is a system used in BMW vehicles, and so on. That also looks about right. And that's it. Now, if you don't want to deal with all this complexity yourself, as I've said, we have the website content crawler, to which you can just pass the URL of the website you want to scrape, and it deals with all the hard aspects of scraping, with the blocking and the concurrency and the extracting, and it gives you just the simplified content that you want. And now that's really it. Thanks so much for your attention. It's been a great privilege talking to you here. If you look at the code that was used in this presentation, we've published it in GitHub under this URL, so you can run the examples yourself and see that they work. Oops, can you put the presentation back, please, for 1 second? Yeah. Thank you.